Thank you.
First of all, thanks for inviting me, and I apologize for 3 consonants in my name, but don't worry, you cannot pronounce it anyway. So how can I move it? Yeah, next. Yeah. This is the motivation of our work. If you look at that, 20 to 54% students fail to complete their degree in normal university with face-to-face education, 78 in distance education, and 93% in MOOCs. These numbers are very, very high. And retention is obviously the key issue to address these issues. I have here hyperlink so you can get to the sources, but this doesn't work. This system doesn't allow me to use it. Sorry. So this is the way how we, this is the model which is applied to the Open University. At the end, I will show you another model with which we experimented briefly. We have presentation which starts, then there are assessments, TMAs, tutor marked assessments, and in between there is interaction of a student with VLE system. At the end there is final exam. We have demographic data, which is this is what we have at the start of the presentation. They are static to some extent. Obviously then we have assessment data, VLE activities, and also we have the conditions which the student must somehow meet to progress to complete the module. And the idea is to find students, identify students who are at risk as early as possible so that the intervention is efficient and meaningful. By meaningful means there is still time to save the student. So the time is very important for this problem. This is type of data which we have. Demographic data is age, gender, IMD, postcode, etc. Presentation related, I like the term fluid. Data are VLE logs, TMA scores, CMA, which is computer marked assessment, etc. Weights and final module, and obviously these data are aggregated and we take them every day. We download every day from the central system. Now this is a very simple example just to convince you that VLE is important. We do it in more sophisticated way, but this is just to show that VLE data can change the whole scenario. We will have 3 demographic data, which is whether the student is new or continuing, the gender, and previous education, and then we will try it with VLE and without VLE. And the problem is to evaluate whether students will submit and scores more than 40 points on the scale from 0 to 100 with the first TMA. And we use the following values. Education, as you know, we can have no formal education, so there are 5 different values of education. VLE, we just count clicks without saying what the click means in this very simple model. We use more sophisticated. This is just to show you the idea. So no VLE engagement up to 800 clicks. New or continuing student, and obviously gender male and female, and goal is TMA 1, submit and scores more than 40, which is pass, and the rest is fail. And these are real numbers from real students. If I don't consider, if I don't take into account VLE, the probability is 18.5% of new student, male, no formal education. So failure is 18.5%. If I take into account clicks, and there is no click, so it goes up to 64%. And if the student is clicking heavily, whatever it means, so it goes down to 6.3%. This is just to convince you that VLE matters. And I will show you what we do with VLE later. Now, why TMA1? Why the first assessment? Well, typically, the main problem are level 1 students. And we would like to know whether the first TMA is a good predictor for the overall success in the course, in the module, and whether there is enough time to intervene, because obviously we have still second, third, etc., typically 6 assessment, A to A, up to A6. So at that moment, we are at the level of A1. We know the history, and we have some future to change it. So let's see whether TMA1 has enough power to say something about the final result. So we will try to estimate what is the probability of a student to fail at the end given result of TMA1. And you will see some numbers which are really interesting. This is one module. 96% students who fail TMA1 fail at the end. You probably think that it cannot be worse. Believe me, it can. This is another example. So you can see, obviously, it's the start of the presentations. Student starts at the university, at the Open University, and this is the first presentation. So the start is very important. Now, we have to go back in time a little bit. We must somehow start predicting before the first TMA, so that there is still time to do something to help the student. In fact, the VLE system opens now about 3 weeks before the start of the presentation. So we start predicting at the start, at the opening of the VLE system. And we've got some very interesting and sometimes criticized also results. In one specific module, we found a pattern which discovers that students who satisfy the pattern at the start of the presentation, pattern from VLE activities from the opening to the start. So they have 14% chance to complete the module. And obviously we were criticized for that. It's just one specific module, but I just want to say that this VLE is very important even before the start of the presentation. Okay, so how do we do it for real? Obviously we don't only count clicks, but each click has a label. Each click has a meaning. So the labels are, and the meaning is, the label is semantics. So it's called activity type, and examples are homepage, forum, which means student did something. Homepage is where the student starts with the VLE system. Forum is obviously where the student contributed to the forum or did something with the forum. Glossary OU content is a web page with the study material, which is somehow structured. The rest is self-explanatory. Perhaps a resource is typically PDF, which the student can download or read from the screen, subpage, etc. The dictionary of these activity types is something like, counts something like 30 items, but say 15 or 12, 15 are more frequently used. And out of these, we select now typically six, the most informative activity types. And they are selected based on the criteria of maximum relevance for the prediction and minimum overlap, minimum redundancy. And obviously 6 would be difficult for me to show, so I am using here selected four activity types, which is forum, subpage, resource, OU content, and obviously the residuum is no activity. And in every week, student can engage in any combination of these. So student can do something on a forum and read the resource. Obviously, there is only impossible to combine it with no activity. No activity stands alone. So these are all possible combinations which student can engage in every week. And the line below is how we show it. And we can create something which we call activity space. Activity space is obviously each row corresponds, say, a resource in row 1 means read textbook 1, page 50 to 70. Resource in week 2 means read something else, so it's also indexed by time. Time goes from top to the bottom. Every week is one row. And this is just part of the activity space up to the first TMA, and it goes on, second TMA, etc., etc. And we have 3 results potential. Submit and pass. That's the green bubble. Submit and fail, which means submit and score less than 40, and no submit. And this is a typical example of, this is a trajectory of some student who was successful. Started first week when the VLE opened, did something on the OU content and forum. Second week had rest, and then OU content, resource, and subpage, etc., and eventually got down and submitted the TMA and passed. This is another example of student who didn't submit. Started with the OU content, nothing, and then there is forum and resource. This is typical panicking pattern. On forum, somebody told him or her, you are in trouble. The last week, student tried to do something with it and then resigned. I will return to this diagram, to this activity space again, because this not only maps what the student has done, but also what the student hasn't done. And this is important for recommending. So we will get back to this diagram later. So in fact, we somehow map the study materials, through this kind of activity type filter to the activity space. And if we do it for the whole cohort, we will get something like this. These are all trajectories from start to the first TMA level. Thickness of line, color of line means how many students go that route. If you think about it, so many students worked and studied and passed. Relatively few students submitted and failed. And quite a lot of students didn't submit, which is this one. Imagine that we will remove from this diagram everything which goes to the red and yellow bubble. You will get something like this. And these are all possible ways how you can study this course from start to the first TMA and succeed. So you can organize your study as you wish. As long as you are within this diagram, somehow you are very likely to succeed. We call it a module fingerprint. Now, based on the information we have, we built 4 different models, and then these models then vote. So the first model is Bayesian reasoner, which is more complicated than the one which I showed at the beginning, but still it's calculating the probability of a student to pass or fail. Then we have two models which are using case-based reasoning. It's like in a legal system. We have the student, which is in the center, the pawn in the center, and around the students are his or her colleagues who are closest to, in some sense, to our student, and we judge the result from the results of these colleagues, obviously in the past. So we are using previous presentation, always previous presentation, to reason about, to predict the current one. We build the models using the previous presentation and apply it to the current presentation. If there is, we have usually presentation which start in February. They have letter B, January, February, AB, and then we have J presentations which start in October. We are trying to match J presentation, use previous J presentation for current J presentation, because obviously there are Christmas and this kind of, we would like these two presentations to be as similar as possible. Sometimes we don't have previous presentation, in which case we do different tricks. For example, we are trying to find something which is very similar in certain sense. In one case we have already done, we had a presentation which consisted of 4 different parts, blocks, which were practically the same in a sense of activities, student activities. So say reading something, elaborating something, writing something, then discussing, etc. So we use the first, we call it Ouroboros model, which is the snake which eats its own tail. We use the first block to build the model and apply it to the second and third, then obviously for the third, first two, etc. And it worked. It's not as good as if you have exactly the same presentation from the past. The last, so we have two nearest neighbors, which is first one is demographics and the second one is based on VLE. And then we have a classification and regression tree. So out of these 4 models, we calculate 4 predictions, and then these predictions vote. And if there are more than 2 predictions which predict student is at risk, so we say student is at risk. This originally, we were sending the predictions to the module teams using spreadsheets like this. This is standard Excel spreadsheet where each model has a column here, and a student who was predicted as at risk in the past sometimes is each row is a student, and students who was predicted in the past as at risk is yellow. Now obviously costing can do the same, but in addition to that we built a dashboard, and this dashboard consists of a number of views. This is a module view. As you can see, on the top is the time machine. We would like users to be able to look at in the past. He who controls the past controls the future. We believe that he who can inspect the past can improve the future. So you can go now. We are in this case in week 15 of some of these modules, but we can go back and see how this module looked in the past. The blue bars are average score of TMA in the previous presentation, the one which were used for model building. The yellow bars is the current presentation. The blue line is the average VLE activity in a week, of the past presentation. The yellow line is the current presentation. As you can see, we have also two different calculation of weeks, because there is a normal week calculation, and there is the bottom part is the one with Christmas breaks and this kind of free time, but the students still can obviously work and do something. So this is the top part of the module view. This is the bottom part of the module view, where we have the summary of what is happening in the module. What might be interesting, so there was 1,520 students here. What is interesting is the last item on the top row, which is change of submitted TMAs compared to the previous prediction. And here it's 1,000%. That's because before there was no submission. We are somewhere in the middle, and now there's something submitted. So dividing by 0, we have here just number 1,000 as kind of placeholder for infinity. The middle part is explanation. What is it all about? What is the meaning of these traffic lights? And the bottom part, each line is a student. One line is one student. And you can see that the second row was open, the prediction, and there's KNN, K nearest neighbors on VLE says no. K nearest neighbors on demographics says yes, and the other two says no. So the prediction is that the student won't submit. Then we have also final prediction of the final result, which is pass, because the student has already passed for, submitted for, and successfully submitted for previous TMAs. And at the very bottom of this module view is a filter where you can select region, gender, specific student, whatever you want, education, occupation. You can just filter the whole cohort into in accordance to all of these type of typically demographic data. If you click on one of these rows of one of these students, any of these, as you can see, it's anonymized. That's how we do it. So if you click, you will get a student view. And this is page or screen which is specific for this blurred student. And you can compare performance of the student, which is the yellow, to the performance of the whole cohort, and both in terms of TMAs and also VLE activities. So this is the top part, obviously, again, time machine. The bottom part has another information about the student. First of all is this target. Our student is in the middle, the blue pawn in the middle, and the current cohort is upper right sector. Then there is the previous one is left. It goes anticlockwise, and these are the nearest neighbors in terms of demographics and VLE. At the moment, there is a slider which is 50-50, which measures 50% weight of the demographics and 50% of VLE. Unfortunately, it's not live, but if you move it, so the pawns will move, and you can change the balance. You can say, I would like to see say, 80% VLE importance and only 20% demographics, etc. Each of these red or green, in this case, pawns are clickable, So if you click on it, you will get that student and you can inspect the student. On the right part is the prediction for the student. You can see first two predictions were submit and justification, because you would like to explain, whoever is recipient of this prediction, why we believe in that. And the last one is, last prediction is submit, and in reality the student didn't submit. The very bottom part is activity recommender, which is personalized for each student. And this activity recommender, now I am referring back to the activity space. We know what the students haven't done, so we can recommend. We know what is needed for TMA, and we can recommend what to do to somehow pass, submit, and pass the TMA. There is a little bit tricky situation here. Imagine that student missed, say, 4 weeks of studying resources, and there are 2 weeks to TMA. There's no point to tell him, do these 4 weeks. So we somehow try to prioritize. We try to reason about what is absolutely essential for getting past the next hurdle. At the moment, we are developing a technique which is based on analysis of text. We read text of study material and try to read what is required for TMA and try to do some reasoning. So activity recommender is personalized for every student, but it's still work in significant progress. Okay, and then this final part of the dashboard, which is tutor view. If the tutor takes the prediction and justification, so probably tutor should somehow do some feedback, do some intervention, and we would like to record what the tutor has done and why, and also whether the prediction was useful or not. Now, this is the number of modules which we supported so far. We started in 2014 with 2 modules, and at the moment we support 3 modules, plus still some of the 13 modules from October. In total, we supported since the beginning about 70,000 students. This is interesting. We also calculated what is potential financial impact from retention. And we took 32 modules, which have more than 1,000 students. We calculated number of students who failed and decreased this number by 10% of the failure. And if we take into account the university fee and multiply the number of failed students, saved students, these 10% by the university fee, we will get £7,300,000 in a single presentation. We don't. I'm not saying that we have saved these students and saved this money. We don't support all of these students. We support only some of them, some of these modules, which will give us, if this reasoning is correct, saving about $2.5 million in a single presentation. I'm still not claiming that we saved $2.5 million, because retention equals prediction plus intervention, and it's kind of whole system which somehow must respond. But this is just to give you estimate what can be achieved, not has been achieved, can be achieved. Okay, now we've developed, because we want the whole community to somehow participate. So we've developed a dataset, anonymized dataset, anonymized by very strict rules used developed by Harvard and I think MIT. And we published this learning analytics data set on our web page and also on University of California Irvine database, which is the biggest database for machine learning. And we believe that clever people will use this data set and start developing some interesting applications, and we will probably benefit from that, hopefully, as well. The whole community will benefit. You can download it. It's been certified by Open Data Institute and released, as I said. It's available under CC BY, and it's on this web page available. I've also brought some leaflets which are on the table outside, so you can take them. Okay, so this is end of my first part. Not yet. I have second part, which is presentation which I'm presenting for the first time, and I was using, our model is very specific for the Open University, but there are other type of universities. So I contacted one European classroom-based university with the engineering program, and I got some data, and we built simple prediction, and this is the first time I'm presenting that, and you will see it's really, really simple model. So their study year is organized as follows. It's 15 weeks of lectures and tutorials, followed by 6 weeks of exams, which is in the winter term and winter semester, and summer semester is the same. They have the following. For each exam, they collect credits according to the complexity and difficulty and importance of the subject. So there are important dates, which is end of the winter exam period and end of the whole academic year. At the end of the winter exam period, if they don't earn 15 credits, they must go. They are deregistered. If they earn more than 15 credits, they can continue. If at the end they get less than 30 credits, they fail. If they get 60 and more credits, they pass completely. And if they have more than 30 and equal and less than 60, they are allowed to re-register at the university and somehow try to earn the missing credits in the next years. And this is how it looks like in time. This is the number of credits. They are on the y-axis, on the vertical, and on the horizontal is time. And you can see these three groups. The dashed line are STEM subjects, because it's engineering school, so it's important for them. And you can see how they develop in time. What is interesting is that if you look at that in detail, so at the beginning, I will magnify it. At the beginning, you can see that very early they somehow start splitting. You can also see clearly the Christmas period. So in fact, the problem is the whole cohort somehow studies and starts splitting slowly. We would like to find as early as possible when we can identify these three streams. Because the earlier we find it, the more time the academies have to intervene and save students. So the yellowish part is the critical part. We did it in the winter term, applied in the winter term only at the moment. And this is when we magnify it. You can see what is important is that at the start of the exam period, already you can clearly identify these 3 groups, which means they started earning credits sometimes during the semester for different home works, kind of what we have as TMA, so they had something similar, so they got some credits already before then. Now, these are the data which we achieved this year, is the last value, in February. We used 2013-14 data for building the models, 14-15 to validate it and applied it, and the tutors used 3 interventions, and these are the results which they achieved. I am not claiming that it's all because of our predictive modeling. Maybe 2015-16 cohort was very clever. Maybe the previous one wasn't. I don't know. I'm just giving you numbers. And I think it needs obviously more investigation, more research to somehow evaluate what it is. But the trends are quite clear. And this is real end. And these are the references which I mentioned. Am I okay with time?
Yeah. Sam, you have any questions for? Just a really quick one. On the results that you just showed.
Yeah.
There was 3 interventions by the tutor.
Yeah.
Presumably the students had visibility of those predictions, so it wasn't just those 3 interventions that made.
No, they
change.
invited. They found those who were yellow and red,
Yeah.
and then invited them. And it was before the exam period, and so it was relatively late. So they advised them how to organize exams. They said, okay, if you do mathematics and followed by some constructive geometry, which was another very difficult subject, and if you do it one day and another day, so you probably fail the other one. So take proper time, organize it. So they advise them how to do the rest of the exam period.
Hi. Hello. Sorry. Firstly, both professionally and as a stats student, thank you. That's one of the most interesting lectures I've seen. That was great.
I don't do it usually. Interesting. Okay.
No, that was great.
Thanks.
The question was, how did you go around collecting the underlying data and getting it in the right structure so that you could do this analysis on top? Did you build a data warehouse?
Yes, we have a succes system at the university, and we collect it from. This is done by the university, and we just take the data from the university system.
Do you know if it's a standard Kimball data warehouse model, or is it a particular tool?
It's a SAS database.
Oh, SAS. Okay. Thank you.
Again, really interesting presentation. Just a question, have you thought about how you effectively operationalise that? I see you've done it with quite small numbers of modules. Have you had any thoughts how that scales up?
We expect a good question and burning question. We have, at the moment, we are rebuilding the whole infrastructure, which will be done. At the moment, we are doing just the last test of security, data security, because this is very tough at the Open University. And we will have completely new infrastructure, and we hope we will be able to support something like 60, 70, 80 modules.
So a very quick question. On the first half, when you were developing the predictive model, was that developed on a individual course-by-course or module-by-module basis? Or
No. It was developed for the as a generic system, and it was applied to different modules. Obviously, for some modules where, for example, there was no history, we had to tweak it a little bit.
Hello. Sorry, that was really good as well. In terms of the machine learning code, is that something you're making available as well in your predictive models?
I would say I'm surprised by the question. Probably yes.
Thank you.
Sorry, me again.
It's done in the R language, by the way, these models.
Are you using standards to store this data, the collection points like, I don't know, Caliper, or are you using any of the standards that are out there for learner analytics?
What we are doing is we are taking the data every day from the SAS model, from the SAS database, download it to our database, which is MySQL, and this is used for prediction.
Hi there, Mary Schlippy from the University of the Highlands and Islands. My question is about, do we know if the student's access to a dashboard is more likely to create a behavior change than an intervention from a tutor?
Students don't access at the moment the dashboard. It's not that we wouldn't be able to support it, but the policy at the moment is that this is used by course teams, tutors. That's it. ALs, which are the associate lecturers.
Hi. When you're building your predictive models in R, what percentage accuracy do you generally get when you're testing them?
We measure it in terms of precision and recall. Precision, just to explain, is how many students we predicted as at risk were really at risk, and this is about 80%. And recall is how many students who were at risk we predicted. So what was the coverage? And this is about 70–80% as well. At the beginning, we had very low recall for a simple reason, because the module team said, okay, don't give us everything, give us just the top of the top layer of the cohort, the most vulnerable, because we can't handle it anyway. So in early times, we just decreased the recall. We just took those who were really in trouble. Now it's about 70–80%, which I think is, I don't think we can improve it. Well, you can always improve everything, but I would say it's already reasonable.
When you were talking about the interventions in that last model, so you said the 3 interventions had an impact. Have you looked about how you might assess the effectiveness of the interventions? Because I expect most institutions have some tutors who are very good at affecting change and some who are, should we say, less good.
The answer is no. This is really new, and it's not, this intervention is not our responsibility. We just produce the predictions. But there is example, I think it's University of Karlsruhe in Germany, and they built a structure which is for, say, 5 students who are identified as at risk. They assign 1 PhD student, we just try to help them. For 5 PhD students, they assigned 1 junior, whoever, lecturer, and built some kind of tree structure, and they say that dramatically, really dramatically improve retention. But in this case, we just provided the prediction, and the rest was problem of somebody else. It's not our main task. It was just, we just wanted to show that something can be done with the traditional university, and we can do it.
So which university was that?
Sorry?
Which was the German institution?
Karlsruhe University, Karlsruhe. But this data didn't come from Karlsruhe.
I think, because I'm from a student support background, and a lot of the work that I've been doing has sort of been like manual implementation of analytics this year. So we've been acting a little bit like a super tutor role. And I think where we've had, say, 3 or 4 interactions with individual students, we're seeing a similar kind of result. But it's then feeding that back down to the personal tutors, where, but at the first multiple point that they can upscale it to us, which has shown similar kind of results, actually.
We cannot somehow affect it, this, what they do with the intervention, how they do intervention. It's not the Open University, and that's it.
Hello.
But they are keen in doing that.
Hi, Richard from Solution Path. I'm particularly interested in the demographic versus the activity data in the virtual learning environment. I'm assuming that there's quite a significant amount of activity in your VLE. That's because that's your primary delivery model, right? Whereas I think most institutions will have lots of different touch points.
Yeah, go ahead.
So I'm particularly interested in how valuable the demographic indicators are versus the actual activity data.
When we started that, so we found that demographics was very important. And I was disappointed, because I expect that VLE activity should be more important. It shouldn't depend on who you are, but what you are doing. But then we realized that we put into demographics also previous results of TMA. So in fact, we cheated. And when you remove that, I got comfortable, because really demographics somehow fades away.
You carried the bias into the model, is that what you're saying?
Yeah. That's what I was disappointed, because early results indicated that it's really biased towards somebody. But in fact, it's not. It was our fault, because we, at the beginning, put TMA1 result into... We had it as, not demographics, but as static, in a sense that you cannot change it. So your previous results in the current course, you cannot change. And we put it into static, and we call it demographic. But if you remove that, so it's okay. It's about what you are doing, not about who you are.
Okay, so you're saying it's all about what you do, not about who you are, right?
Yeah, there is certain bias, obviously, but it's not very significant.
Cool, because that's what we did at NTU, right? So, okay, thank you.
I just had a quick question about the tutor dashboards that you showed, and you talked about prediction and then intervention, and what was the take-up of intervention by the tutors? I guess it was a pilot group, so it might be self-selected.
This dashboard is in operation for about 3 months.
Okay.
So we have some responses, mostly positive, but we don't have enough to evaluate it as a kind of, it's not enough data at the moment. Obviously, what the Open University did, and I think it was very good, they instructed, they selected something like super tutors, who are familiar, who speak tutors' language and are familiar with the dashboard. And they then train or instruct other tutors, and it's very successful because they understand the problems of other tutors, and they are somewhere between the tutors and us who are developing these things. And I think this was a brilliant idea, and works. And it wasn't our idea.
If there's no more questions, then if we could please thank Zenit for his presentation.